Alright, time for another review video. This review video will be on measurements. Specifically, we're going to talk about the meter sticks, the graduated cylinders, and the triple beam balances. There's a few things you need to know about them so that you're using them more correctly. Fortunately, with the video, I won't be able to get all that close, but I'm going to try to do my best to make sure that you can get a good idea of how these pieces of equipment should be used. First of all, the meter stick. This is a meter stick. You'll note there are two sides. There's printing on both sides of the meter stick. In the science classroom, we use the metric system, so we will always use this side. The side that's numbered from 1 to 100. That is the meter stick side. That is the meter side of the meter stick. It's also the side where the little markings are closest together. And if you look, you can see on this side of the meter stick, little tiny lines are really, really close together. On this side, the lines are really far apart. We use the side where the lines are close together. Reason for this, it gives us more accurate and precise measurements. It'll give us measurements that are closer to the actual correct value, that's accurate. It'll give us more repeatable measurements. If we all measure the same object, we should all get pretty close to the same thing. That's precise. Precise means repeatable. Now, a few things you need to know about this meter stick. First of all, it might be kind of hard to see. If you look at the end of the meter stick, it's kind of chipped up. It's kind of rounded off on the end there. And that's bad for measurement. If we take whatever object we're measuring and try to stick it right up to the end of that meter stick, it might not be lined up with 0. And what that's going to do is it's going to throw off our measurements a tenth or two. We don't want that in science. We want as accurate a measurement as we can get. So the way we fix that is instead of putting the meter stick up to the end of our object directly, we start off at a 1 or maybe a 10 and line up the end of our object with that marking instead. And then all we got to do is subtract that from our final measurement. So I like to use the 10 marking because it's far enough from the end to be pretty accurate. So I'll line the end of my object up with the 10, measure it out, and then subtract 10 from my final value. That'll increase your accuracy tremendously. That'll make the precision much better as well. Also, we need to know what these little tiny markings mean. If you look at this meter stick, you'll see that it's numbered 1, 2, 3, 4, 5, and so on. The meter stick is marked off in centimeters. The 1 would be 1 centimeters, the 2 would be 2 centimeters, and so on. The 10 would be 10 centimeters up through 100. Each of the little teeny tiny lines in between, those are tenths of a centimeter, or 0.1 centimeter. So the first line after the 2 would be 2.1, then 2.2, and so on. It's important that we know what these individual little numbers mean so that when we're writing down our measurements, we get the correct number of place values after our decimal point. If an object isn't exactly on the 2, we don't want to call it 2. We want to say exactly where it is so that we get the most accurate measurements we can. Say a few things about the graduated cylinders next, and this is the graduated cylinder, you can see. Again, it's marked off on the side. This time, this graduated cylinder is marked off from 0 to 100. These are marked off in milliliters. This is a 100 milliliter graduated cylinder. Again, we got to know what the little markings mean that are on this. And they're kind of hard to see because they're in white. We go from 90 to 100 here with 10 individual marks in between. The difference between our two numbers is 10. We have 10 markings to work with. Each little line is 1 milliliter. So it goes from 90 to 91 to 92 and so on. Now, a few things about the graduated cylinder. The 100 milliliter graduated cylinder is marked off in 1 milliliter increments. There are smaller ones that are marked off in tenths. There are bigger ones that are marked off in 2 milliliter increments. They all differ from one to the other. Your best bet is just to simply take a look at any two numbers on it, like I did with the 90 and 100. Take that difference and divide it by the number of divisions. That'll tell you exactly how many milliliters each individual marking is. It's important that you figure out what the markings are before you try to read it. Other things you need to know about the graduated cylinder. Whenever we put a liquid inside this graduated cylinder, it sort of sticks to the walls of the graduated cylinder. And what that does is create a curved surface, where it's high on the sides of the glass and it's low in the middle. That curved surface is called a meniscus. When we read the graduated cylinder, we always read from the lowest point. We read from the bottom of that curve or meniscus. Another thing you have to keep in mind when reading the graduated cylinder, you should always have it on some kind of flat, stable surface. You should never hold the graduated cylinder when you're trying to read it. So when you hold it, the surface might not be level. That's going to throw your readings off. And again, that's going to make your measurement inaccurate. It's going to give us a lack of precision from one group to the next. And again, we want to make sure that we have accurate measurements. Again, accurate meaning correct. We want precise measurements. Again, precision meaning repeatable. We want everybody to get the same thing. To do that, make sure that the graduated cylinder is on a flat surface and make sure that you get down on its level when you read it. Don't read it downward. Make sure you get down on its level so your eyes are level with that meniscus when you read it. Now, there are different size graduated cylinders. You choose the size that is most appropriate for what you're trying to measure. This is a 100 milliliter graduated cylinder. If I wanted 2 or 3 milliliters of a liquid, this thing's way too big. It's going to throw off my accuracy. So I choose a smaller one that will give me a much more accurate measurement. If I needed to measure something over 100 milliliters, this is too small. I don't want to have to measure more than once. If I have to measure 2 times, 3 times, 4 times, every time I measure, I introduce error. So if I had to go over 100 milliliters, I'd choose a bigger graduated cylinder, one that would fit my volume better. Always choose the piece of equipment that fits your volume best. That will give you the highest degree of accuracy and precision. Final piece of equipment, the triple beam balance. Now, a few things about the triple beam balance. These things can be a little tricky to use. First of all, if we take a look at this balance, it's not quite zeroed. A triple beam balance needs to be zeroed in order to assure that it's correct. To zero the balance, there's a little knob on the end that you can tighten or loosen that will adjust where that 0 point is. Sometimes we just have to play around with it until we get that needle where we want it to be. Once we have it zeroed, then we can take our measurement. Another way we can get around this, if we want to save ourselves a little time and not have to worry so much about zeroing the balance out, is to do a process called measuring by difference. And I've just finished playing with that little knob there, and you can see now I've got my balance zeroed. Now I'm pointing to that little line like I'm supposed to. If we don't want to mess around with that, what we can do is called measuring by difference. If, let's say I want to measure the mass of some chunk of metal that I have, well, instead of just putting the chunk of metal on the balance and measuring it out, I can get a beaker or something, stick that on the balance first, slide all my things around, measure the mass of the beaker, then stick my chunk of metal inside the beaker and measure the mass again. If I subtract those two numbers, I'll have the mass of my object. And what that does, that measuring by difference, what that does is remove some of that zeroing error. So if a balance isn't perfectly set up right, it's okay. That incorrect marking will transfer through both measurements and basically eliminate it. Now, if we do have it zeroed, we can go ahead and put whatever we're measuring directly on the balance itself. So I'm just going to stick the graduated cylinder on the balance. When we work with this, what we want to do, you'll notice there are 3 bars here. One is marked off from 0 to 500 in 100 gram increments. The bar in the back is marked from 0 to 100. This one is marked off in 10 gram increments. And the bar in front you'll see is marked off from 0 to 10 in 1 gram increments. We always start with the big one. What you want to do is you want to start with the middle balance beam and move it 1 notch at a time. You can see the little notches in here. These back 2 sliders have to be in those notches. We go 1 notch at a time until our needle goes to the bottom. When it goes to the bottom, we just back it up 1. So back to 100. We then move to the back beam, and again, 1 notch at a time, just sliding it over 1 notch at a time until the needle falls. And there the needle fell on the very first one. When it falls, again, I back it up one. Then I start working the front slider. This is where I make my fine adjustments. And I work this thing back and forth, and sometimes it's best to work with a pencil with this, that way you're not moving the beam too much. You're not having to wait for it to stabilize again. I slide it back and forth till again my little line is pointing to the 0. Once I've got that, then I can add the 3 beams together to get my final measurement. Kind of hard to see on this one because the numbers are so small, but this front beam marked from 0 to 10, again, just like the meter stick, has a bunch of little lines in between it, and just like the meter stick, each one of those are a tenth, or 0.1. What I do is add my beams together. I have 100 plus 0 plus 1 point something. And again, you're going to have a hard time seeing this. It is about halfway between 0.8 and 0.9. So I would call that 1.85. That 5 at the end tells me I'm halfway between 0.8 and 0.9. So I say 101.85, adding those 3 beams together. Again, measuring is one of the most important things that we do in science. We try to make sure that everything that we present is based on measurement, these quantitative observations, these observations with numbers, because they're universal. They mean the same thing to everyone, everywhere, all the time. So make sure we do those right is one of the most important things that we have to learn in physical science.